In this video, we will talk about abstract classes. Before viewing it, you should study Foxes and Rabbits, Chapter 10, Version 1. We see that in version 1 of the simulation code that foxes and rabbits have many similarities and that the update code is very similar also. In order to reduce this redundancy, we can introduce a superclass called animal. We can place all of the fields in animal that are common to rabbit and fox, age, alive, and location. Dealing with the run and hunt methods is a little more complicated. We actually rename those to act so that there will be an act method that will replace run and will replace hunt. And this supports information hiding as well as allowing us to have a single superclass. And now we can significantly decouple simulator. Before, it had different versions, different parts of update in order to deal with the different update steps for foxes and rabbits. Now it can just have one update, making it significantly simpler and decoupling it significantly from how fox and rabbit work. Now it just deals with them as animals. So we have a problem. Static type checking requires an act method in animal for the update method in simulator to call. But there's no obvious shared implementation since foxes hunt and rabbits run, and there's not really much common code between those two. The solution is that we will define the act method in animal as abstract by placing the abstract keyword in front of the method signature, and then rather than having a method body, we just have a semicolon. So it looks like this: abstract public void act, and then the parameter list is a list that contains animals or can contain animals called new animals, semicolon. So no body, and we use the keyword abstract at the beginning of the method declaration. So abstract methods and classes are a little different from the classes and methods that we've seen so far. Abstract methods have abstract in the signature, they have no body, and when a class has abstract methods, that makes the class abstract, and therefore the class cannot be instantiated. In order to have a useful implementation, there must be concrete subclasses that complete the implementation. They provide some sort of implementation for each abstract method so that you can have an instantiable class whose methods can actually be invoked. So this is how animal looks when we make this change. We leave out the fields and other methods because all we want to illustrate is how act looks. And so we see that we have this single line for act: abstract public void act accepts the list of animals called new animals, and then a semicolon because it has no body. And this says that anything that inherits from the class animal will need to either declare and define act with an actual body, or declare it as abstract, in which case that class will be abstract and won't be instantiable either. So again, act here doesn't do anything at all. It's just a promise that subclasses will implement act, or possibly leave it as abstract and not be instantiable. So then, just to review what we've talked about, abstract methods allow static type checking without requiring an actual implementation for the method. They are simply a promise that subclasses will implement this method. They will provide an actual method body. And typically this is what they do. Sometimes the subclasses may be abstract and may simply be promising that their subclasses will have an actual implementation. So abstract classes then are incomplete subclasses. We can't instantiate them because we don't specify the actual code for ACT. We just say that subclasses of ours will have code for ACT. The ability to use abstract classes supports polymorphism because it makes the range of classes that we can create a superclass over much broader, because they don't necessarily need to have any kind of common implementation. And indeed, there does not need to be an implementation at all. We can just promise that subclasses will implement.